All right, so we're doing this in two parts because my computer is doing some interesting things. Anyway, so looking at this graph here now, if I want to check and see if this is actually the maximum, I can go to Second, Calc, and then I'm going to choose maximum here because it is open downward. Remember, it makes a frown, it's open down. So I'm going to go to the left, and then I'm going to go to the right of where I think my maximum is, what looks to be the highest point. Hit enter, guess, and it says maximum is at 2.5 and y equals 28.125. So that was correct. All right, so let's take a look then at number 2. All right, so let me move this bar here. Oh, it's rather annoying. There we go. Okay. So looking down at the next one, it says a square picture has a frame that is 3 inches thick all the way around. The total side length of the picture and frame is x inches. Which expression represents the area of the square picture without the frame? If you get stuck, try sketching a diagram. All right, so we are going to sketch a diagram. That is the best course of action here. We're going to start. And we have a square picture frame, so all the sides are the same, and it is measured with 3 inches of the frame on either side, right? And so it says the total side length of the picture and the frame is x inches. So that means this whole amount is x. It says which represents the area of the square picture, this part right here, without the frame. So the area of the frame would be this 6 inches, right? Or it would be this x times x would give us the area. However, because we want to calculate without the frame, the length of this side of the actual picture is x minus the 3 inches on this side and the 3 inches on this side. So x times 6, or x minus 6. And then that also means that the other side I'm multiplying it by, right, is subtracting these sides here, and so this would also be x minus 6. So x minus 6 times x minus 6 gives us the area of the inside of the picture. All right, our next one. The revenue from a youth baseball game depends on the price per ticket. So again, remember that's a revenue expert, that's part of their job. Here's a graph that represents the revenue function R. Select all the true statements. R of 5 is a little more than 600. So if I plug R of 5, yep, that looks to be just above the 600. R of 600 is a little less than 5. So if I input 600, that's way beyond this graph. So that is not true. Remember, this is the input, this is the output. So this is the X, this is the Y. The maximum possible ticket price is $15. Yeah, so it looks like at $15 right here, we have our maximum right there. So we wouldn't want to raise the price any more than that, or it starts to go back down. The maximum possible revenue is $1,125. It does appear to be between $1,000 and $1,200, so that looks to be true. If tickets cost $10, the predicted revenue is $1,000, also true. And letter F, if tickets cost $20, the predicted revenue is $1,000. That is also true. All right. Let's look at number 4. A garden designer designed a square decorative pool. The pool is surrounded by a walkway. On 2 opposite sides of the pool, the walkway is 8 feet, so 8 feet this way. And on the other side, it's 10 feet. So this is the diagram. The final design for the pool and walkway covers a total of 1,440 square feet. The side length of the square pool is x. Write an expression that represents the total length of the rectangle, including the pool and the walkway. So if we want the total length of the rectangle, we're looking at x plus, right, 10 on each side. So x plus 20 gives us 1. And then we would need to do that twice, right? Because this length right here is x plus 10 plus 10. And then we also have another length over here. So if we're looking at just the total length, this would be times 2. So you could write that as 2x plus 40. And then likewise, we need to look at the other side here, which is x plus 8 plus 8, or x plus 16. And then again, we need to multiply that by 2 because we have two sides here. So this is also then going to be plus 2x plus 32. So we could represent this as 4x plus 72 because I can combine my x's and combine my constants there. The total width of the rectangle, including the pool and the walkway. All right, so, oh, I'm sorry. You know what? I did the total length the whole way around, but I guess it just wanted the width. So let's say that the width is this one, 2x plus 40, and the length can be 2x plus 32. When it said total length, I just calculated all the way around the perimeter, but I just wanted one side and then another side. All right, so then the total area would need to be, right, one side times another side. All right, so one side times another side means that I'm doing x plus 20, because that's one side, times x plus 16. So here, Miss Lee was calculating perimeter, and I was jumping a little bit too ahead of myself. It just wants the length of this, so the length here is x plus 10 plus 10 is 20, and then the width here is x plus 8 plus 8 plus 6, which is 16. Okay, so then the total area would be that length times the width. Sorry, that was a little confusing, and I apologize. All right, write an equation of the form your expression equals 1440. What does the solution to this equation mean in this situation? So x plus 20 times x plus 14 equals 1440. A solution would mean a length of the side of the pool that gives total area of 1440, including the walkway around the pool. So what value for x will give us this area? An American traveler is heading to Europe, is exchanging some US dollars for European euros. At the time of his travel, $1 can be exchanged for 0.91 euros. Find the amount of money in euros that the American traveler would get if he exchanged $100. So remember, $1 is to 0.91 euros, and we want to figure out if we had $100, how many euros would we get, right? So here, to get there, you're multiplying by 100, right, to get from 1 to 100. So you would do 0.91 times 100, which would give you 91 euros. If he exchanged $500, so the same thing, 1 over 0.91 equals $500 over how many euros would we get? You can calculate that and figure that out. C says write an equation that gives the amount of euros, of money in euros, E as a function of the dollar being exchanged. So our function of euros, or sorry, our function that gives euros as a function of the dollar. So this is f of d equals, now what are we doing here each time, right? So when we have the number of euros, we're multiplying it by what, right? So you want to think about what are we doing to get to the number of euros each time. So in our first example, we multiplied by 100. In our second example, we multiplied by 500. So we're multiplying 0.91 times the number of dollars. 0.91 representing that amount that the euro is worth per dollar. Upon returning to America, the traveler has 42 euros to exchange back into US dollars. How many dollars would he get if the exchange rate is the same? So here then we're going to do the opposite, right? So we have 42 euros and we want to figure out the dollar amount. And we know that 0.91 euros gives us $1, right? So in this case now what we're going to do is we're going to divide 42 by 0.91 to see what we get here. And you notice that we get more dollar per euro, right, according to this exchange rate. And so we should have more dollars after we exchange our euros. So when you divide this, you want to see that you get a larger number, and that can help you to make sense of that. Letter E says write an equation that gives the amount of money in dollars as a function of the euro being exchanged. So now the opposite. So function of euros equals, in this case, it is going to be the euro amount divided by 0.91. And that will give us our dollars. All right, that is it for your homework tonight. Nice and short. If you have any questions, feel free to reach out. Happy homeworking and see you tomorrow. Your code word for today is canvas. Canvas is your code word for today.